Hello, math fans. Dr. Andy Lovelace. Here I'm going to make a series that I did something similar to in Math 125 called Volumes, Volumes, and More Volumes. But this is going to be using 126 methods, which are a little more general. So we're going to set up a double integral to find various volumes. Some are from similar to homework, some are from old exams. But this is something we've talked about quite a bit in class, and I have a careful process for how we do this. So let's go. So step one, we find the integrand. The integrand in this course in Math 126 is always going to be the z. Now, if you take Math 224, we'll talk about what if you wanted to use x or y, which you could. But for this course, we're going to say, let's just assume we're going to use z. So step one is you solve for the z's. That's the only z in the problem. You solve, you get plus or minus. That describes the height. That's like my surface, and it's an upper and lower hemisphere. Now, that's what the students asked me about this on the discussion board, and the upper and lower hemisphere is bothering them. But this does not affect the fact that it's an upper and lower hemisphere. It doesn't affect the region, that piece of it. If you want to see a visual, I'll show you, but part of the point I made in class was you can do 90+% of this without visualizing. So you don't have to let the visualization scare you. Okay, so here's the surface. That's the upper hemisphere. The lower hemisphere is down below. Lower hemisphere, upper hemisphere, upper hemisphere, lower hemisphere. That doesn't matter. In terms of setup, without visualizing, the very next step would be to say, I am going to do a volume from somewhere on the ground up to this surface. Now, if there's a plus or minus, I just sort of capture that. I hold that in my head for later, and I'll worry about that when I interpret at the end. Okay, next step, draw your region. So you will see when I do these problems that I do all of this in like 30 seconds at the very beginning. Set up my integrand, draw my region. For drawing the region, I draw any given xy equations, meaning equations that only have, or restrictions that only have x and y. And in this case, they only gave me one. Done. It actually says outside of this. So that doesn't make any sense. This sometimes happens, and when it doesn't make sense after you do that, then you definitely need to do this next step. Now, if you want a visual, what we're talking about is this cylinder. So outside the cylinder, what we just drew is this. Outside the cylinder. But you can see, if you actually can visualize, that it doesn't go on forever. It stops. How would you figure out when it stops? And that's the whole point of this second step, which is when do these upper and lower hemispheres hit each other? Or in other words, when is z equals 0, which is when you'd have on the ground. So the very next step is find when the surface is hit, which is going to be when z is 0. And that gives me a circle. It gives me another xy equation, and it's a circle of radius 4. So now it makes more sense. This actually does give me a region. So I find it sort of satisfying how mechanically I can do this. When I was a student, I remember this being like, oh, I can almost turn my brain off. Now, there is a moment when you have to interpret, but the point I'm making is we can get pretty far into this problem. Now we're going to describe this region, and we're going to compute. The question on the discussion board is, why don't we cut that in half since it's a hemisphere? Again, the surface and the region on the ground are separate. We want to integrate over that entire region, and then we're going to integrate up to the surface, and we're going to get that volume. That's that thing. That's what we're getting. And we're going to use polar, so we're basically going to do this. Let's let it go. Yay! We're going to go around this way. Now, polar, there's some other things to consider. We talked about the pirate calculus, already theta stuff. So there's some adjustments, but that's how we're thinking about the region as we go around. All right, that was fun. So you don't change anything. You just now describe the region. So now we're ready for the next step, which is I would describe this in polar. I would think about going once all the way around, so 0 to 2 pi. It is all the way around. There's nothing restricted here. And then if I'm in the region and I walk out, it's going to be 2 to 4. So I get the integral from 0 to 2 pi, the integral from 2 to 4 of the square root. I'm going to change this to polar, so it's going to be 16 minus r squared, and then already theta, pirate. So then you're going to compute. I'm going to leave that to you. And there's this moment right at the bitter end where you compute and interpret. So occasionally students say, well, I was just completely confused, so I didn't do anything. No. There's lots you can do. I hope that kind of makes sense. You could do these questions immediately. But if you can't spell the word interpret, you're in trouble. Okay, so here we go. Interpret. I can't think and do this at the same time. All right, so here we go. Let's go here. So I'm going to find this volume. It's going to be this. And this is the number one scary question that students say is, wait, that's not the answer. I need to multiply by 2. And then people come to me later and they're like, what do? I don't know when to multiply by 2. Yes, there's a little bit of visualization there. Now, we might have suspected this back here and the fact that it's a sphere. Maybe we know what that looks like. But we do need to multiply this by 2 because the question did not say above the xy plane. So your final answer is 2 times that. All right, I hope that helps. I'm going to make a few more of these. Let me know if it does. I enjoy making these sorts of videos.